Hello everyone, I'm Giuseppe Riccardo Leone with the National Research Council of Italy. The work in progress I'm going to present is about the pervasive computer vision applied to the intelligent transport system scenario. I will talk about the Smart Passenger Center, a project funded by the Tuscany region whose focus concerns the design and implementation of a pervasive system that monitors all regional public transport inside trains and buses and outside them in the stations and at the waiting shelters. The main objective of the project is to offer proactive support to sector operators with various functionalities, real-time alerts relating to the vehicle flow or any other emergency, but also offline analysis of the data collected to improve the efficiency and safety of the entire transport system. Everything is designed following the privacy by design paradigm, that is, respecting the GDPR, the European law on privacy. These are the project partners, all located and operating in the Tuscany region. There are various companies operating in the ICT and two scientific partners, the University of Florence and us, the Institute of Science and Technology, Information Science and Technology of the National Research Council. We deal with the pervasive artificial vision part inside trains and buses and outside them. And this is the focus of this talk. The Space Computer Vision subsystem constantly monitors activities in all places of interest. It is made up of a pervasive smart camera network whose main task relates to the analysis of passengers, counting people on board or waiting in the streets, counting available seats, recognize any behavior of interest, for example, a fight or someone that falls on the floor, but above all, the full tracking of a person's journey from the first time he or she is seen to the exit from the last vehicle. In addition, a series of auxiliary functions are provided: the detection of unattended object, the detection of a damage on the vehicle, or the detection of dirt and waste for support of cleaning personnel, or the presence or smoke or fire. Each sensor is equipped with the NVIDIA Jetson Xavier, which is one of the most powerful embedded computer available. This is the computer vision pipeline used on this sensor you can see on the slide. The first step is always to classify and locate all the elements in the image with object detection to locate people and objects in the scene. For the identification of passenger, we rely on face recognition, which is also useful to build the model used for tracking people. For better estimates and measurements, we use stereo cameras or depth sensor in combination with color camera. The proposed contribution contain a brief review of the most recent computer vision technique widely used in the image processing pipeline. The space system must be able to reconstruct the complete path of people during their daily journeys, from departure to arrival, by implementing a real-time tracking process of people through the network of cameras mounted on vehicles and in the parking and transit areas. All this must be carried out in compliance with the current legislation on privacy, uh, of no image with recognized people must be stored on permanent media or transmitted over the network. Based on the face, the physical characteristic and appearance, the space system builds what we call the digital footprints of the observed person. That is a mathematical model associated with that person, useful for its recognition and re-identification every time it is seen by a camera. For the construction of a fast and reliable digital footprints, we are experimenting with the deep feature that we found in the work of Wojciech and Alt. simple online and real-time tracking with a deep association metric. The deep feature is a vector of size 128 for each bounding box of the classifier, which represents the main characteristic of the box. To calculate these characteristics, a model trained on millions of human images is used. The main limitation of this approach is the case of a very large bounding box that includes too much backgrounds of information not relating to the person. In this paper, we introduce the Smart Passenger Center space, an integration platform for managing and supporting the operators of public transport system. We focused on the computer vision subsystem of space, which leverage edge computing and smart cameras to offer advanced service in a robust, scalable, and privacy-preserving way. Still in the design phase, the work in progress will explore the interplay between computer vision and pervasive technology and will address challenging aspects related to internode communication and orchestration. Results will be demonstrated in a realistic experimental setup using an installation on test carriages to cope with and tackle the actual issue of the real world. For any question or curiosity, please don't hesitate to ask now or to write me in the future. Thank you very much.